Dear students, this is the fourth part of metallurgy. Our topic, magnetic separation process. This is one of the concentration of a ore process. In this process or in this method is applicable to ferromagnetic ores. Which one is called as ferromagnetic ores? Ferromagnet. The typical example of a ferromagnetic characterized metal is iron. If we have Fe, one of the main component or unwanted component in a ore, now we are using the magnetic separation process. So, the magnetic separation process is applicable to ferromagnetic ores. Right? Okay. So in this process, it's based on difference in the magnetic properties of the ore and the impurities. Our ore contain a two component. One it is called as a ore component, another one is impurity component, isn't it? Here, the magnetic property, it may be present ore component, either ore component or impure component. Now only we are using the magnetic separation process. So the second point is very, very important. Magnetic separation process is based on the difference in the magnetic properties of the ore and the impurities. Okay. So in our textbook, I have two examples. Here the first example, tin stone. This is the ore of a tin metal. When we are getting a tin stone ore from the earth crust, here the impurity, already we know that siliceous matter as an impurity, and also have wolframite. It is a impurity, may be present in tin stone ore. So the tin stone ore contain a wolframite as impurity. How we are remove a wolframite impurity? Just you understand the formula. Here tin stone have a Sn, tin metal only present. Wolframite have Fe, iron is present. Here tin stone is non-magnetic, but wolframite is magnetic. Such a character, it is here used to separate wolframite impurity from a tin stone ore. Okay, right. Our tin stone is non-magnetic, but impurity wolframite have magnetic character. That's why we are introduced into the magnetic separation process to separate a impurity wolframite from the tin stone metal. And the second example, chromite ore and pyrolusite. Just you see the chromite ore, Fe is present, pyrolusite, Mn is present. Okay, so chromite ore and pyrolusite. Here it is magnetic property. Have a magnetic property can be removed from the non-magnetic siliceous impurity. I mean chromite ore. Chromite ore have a two component. One is a ore component and another one is a gangue component. Here our ore is magnetic characterized ore, but gangue is non-magnetic. That's why the chromite ore is purified by using magnetic separation process. Okay. So just you see the apparatus. This is called as a inlet of a. This is a inlet of a ore. I mean, first of all, we are taking a ore, crushed and grind well, make a powdered ore. In this powdered ore is allowed to fall on the inlet. Okay. So here two wheel is there. One wheel is a non-magnetic, another wheel is a magnetic. Both the wheel are connected by using conveyor belt. Okay, right? So here the powdered ore, is allowed to fall on the conveyor belt. What happened? The powdered ore contain a magnetic ore as well as non-magnetic characterized ore, isn't it? So the magnetic substances all are fall into very close to the magnetic wheel very close to the container. But non-magnetic ore all are fall slightly far away the magnetic wheel. So in this way we are separate a magnetic impurity present in a ore or non-magnetic impurity present in a ore. This is known as a magnetic separation process.